objectives on the board today that we are talking all about how atoms are different from each other. So specifically, we're going to look at how the particles in them make them different from each other. So by the time we are done today, you should be able to do a couple of things. One, describe how each part of the atom affects its mass and charge. Define what an isotope is. And then list and describe the 3 types of radiation. Radiation might seem like an outlying topic, but once you learn what radiation is, it will make sense why we are covering it in this section. All right, so let's jump into it. You know by now, and if you didn't know before, you certainly know after yesterday's class, that atoms are made up of 3 particles called protons, neutrons, and electrons. Atoms of different elements have different numbers of these particles, different numbers of protons, different numbers of neutrons, different numbers of electrons. Okay. All atoms that are of the same element have the same number of protons. So if I go out and I discover an atom and I am able to calculate how many protons are in it, I can use that number to figure out what element it is. So if it had 28, I would say that is an atom of nickel, because nickel has 28 protons in its nucleus. This is what we call the atomic number. The atoms on the periodic table are organized by atomic number, increasing atomic number as you go from left to right and then down the table. And different elements have different atomic numbers, different numbers of protons. So for example, gold has 79, aluminum has 13, hydrogen only has 1. Now, you might think to yourself, so if I remove a proton from the nucleus of an atom, it changes what element it is, and that is correct. But this isn't an easy process to do. It's not like you can just reach in with a pair of tweezers and remove a proton. They're incredibly small. The forces binding them in the nucleus with the neutrons are incredibly strong. It's not a simple thing to just reach in and remove one. Okay? But if you did somehow manage to do that, you would change which element you were doing. And we are going to talk about some ways to change the number of protons in the nucleus later. All right, in a neutral atom, the number of electrons is equal to the number of protons. Okay? Because the electrons have a negative charge and the protons have a positive charge, then the atom has no charge as long as those charges equal each other. So if you have 3 protons and 3 electrons, those 3 positives balance out the 3 negatives and you have no charge on the atom. Adding or subtracting electrons from an atom produces what we call an ion. An ion is any atom or group of atoms that has an electrical charge on it. It's possible to create positive ions. Positive ions are created when atoms lose an electron, and there are then more positive charges than negative charges. Okay? I want you to understand that the process of forming ions is backwards to our brains. Because when your brain thinks of subtracting something, it thinks about negative numbers. But what you have to understand is that what we are subtracting from this atom is a negative charge. So it's more like subtracting a negative number. If you subtract a negative number, you're actually adding, correct?
Yeah, keep change. Mm-hmm.
Good. So that's what we're doing here. We are removing a negative charge, and so as a result, the balance is tipped towards positive. It's also possible to add electrons, and when you add electrons, you are adding negative charges, and as a result, you will wind up with a positive charge on the atom. If you are having trouble visualizing this, I often recommend to people that they just simply draw themselves a picture. So think about if you have 3 negative charges and 3 positive charges, when they're all balanced out, they equal 0, right? Because there's 1 for each of them. But then if you were to go in and remove one of these positive charges, well, actually, let's not do that, because remember, removing protons is a very difficult thing to do. So we would say if we remove one of these negative charges, then we're going to wind up with more positives than negatives, so we would wind up with a positive charge. Okay, the opposite is true if we add an additional negative charge. Then what we wind up with is a negative charge on the atom. So draw yourself a picture so you can see how they balance out. And whatever you have left over at the end of it is your charge. So if I added an additional negative charge, what I would have left over would be 2 minus. So I would have a -2 charge on this atom. It's also important to understand that adding and subtracting electrons happens all the time, but adding and subtracting electrons doesn't affect the mass of the atom. Okay? If we're looking at a comparison between mass for particles of the atom, we would say that protons have a mass of 1, neutrons have a mass of 1, and electrons have a mass of 1/1840th. Okay, so they are that much smaller than protons and neutrons. So while they do technically still have mass because they are matter and they take up space, they do not have enough mass to affect the total mass of the atom by gains or losses. Gains or losses of protons and neutrons, however, do affect the mass of the atom. Do we have a question out here? Okay. So we've talked about protons, we've talked about electrons, now let's talk about neutrons. Neutrons are neutral, so they do not contribute to the charge of an atom. However, we just discussed that they do have mass, and their mass is comparative to the mass of a proton. So adding and subtracting them will definitely affect the mass of our atom. When you have an atom that has more neutrons added to it, then you have what's called an isotope. So you can have an atom of helium that has 2 protons. You can't change the proton and still have helium, but you can add more neutrons or subtract more neutrons and still have an atom of helium. It will just have a different mass. The name of an isotope is written by listing what we call the mass number at the end of the name of the element. So the mass number is total number of protons and neutrons combined. For example, if we have an atom of nitrogen, and that nitrogen atom has 8 neutrons in it, it would have a mass number of 15. Because it has 8 neutrons, and we know since it is nitrogen that it must have 7 protons. And when we combine those numbers, we get 15. And so we would write it as nitrogen-15 to indicate this is an atom of nitrogen, but it has more neutrons. So it has a mass number of 15. Many times in chemistry, it's important to know the mass of the element that you're working with. And because elements can have atoms of different masses, because the number of neutrons can change, we need to have an average mass for an atom. Okay. Average atomic mass is the average mass of the element's isotopes, but it's not just a straight up average where you add all the numbers together and divide by the number that you added together. So you can't just calculate it like you would a normal average, because we want to take into account that some isotopes of different elements are more common than other isotopes of elements. Okay? This means that it's going to, the average number is going to skew towards whatever the most abundant isotope is. An example of this would be carbon, which has 3 isotopes. You can have carbon-12, carbon-13, and carbon-14. Okay. So carbon has 6 protons, which means you can either have 6, 7, or 8 neutrons in the nucleus of an atom. However, carbon-12 is by far the most common isotope of carbon, meaning that over 99% of the carbon atoms that you find will have only 6 protons and a mass number of 12. So it would be not necessarily incorrect, but not quite as accurate as we could be to say that the average mass of carbon is 13. Because if we added 12 and 13 and 14 and divided by 3, it would tell us that our average mass would be 13. But that's not what you will find true in nature, because you're going to have way more carbon-12 atoms in your mix. So instead, we do a weighted mass, or a weighted average, and we come up with 12.01, which is indicative that carbon-12 is the most common isotope. So, for an example of what this looks like, okay, is lithium. We're going to write Li for lithium, is the third element on the periodic table, and it has 3 protons, and it has 2 common isotopes. It has lithium-6, which is makes up about 7.5% of the lithium that you will find, and it also has lithium-7, which makes up about 92.5% of the lithium that you'll find. So lithium-6, because lithium has 3 protons, we know lithium-6 has 3 neutrons, and lithium-7 has 4. Okay? Lithium-7 is much more common, but it would be inaccurate to say that the average atomic mass of lithium was 6.5, which is what we would get if we did a straight up average of this. So instead, we're going to do a weighted average, and here is how we're going to do it. We're going to change these percentages into decimals by dividing by 100. So we will wind up with 0.075 and 0.925. And then we're going to multiply them by the masses that go with the percentages. So for lithium, for lithium-6, we're going to multiply by 6, and for lithium-7, we're going to multiply by 7. When we do that calculation, what we wind up with is 0.45 for lithium-6 and 6.475. And when we add those up, we get our average atomic mass of 6.93. So this is the average atomic mass of lithium. Notice how it skews towards 7, because 7 is the more abundant isotope. Okay? All right. Moving on, let's talk a little bit about radiation. Okay? We've talked about gaining and losing electrons. We've talked about the fact that different atoms have different numbers of neutrons. And we have mentioned that changing the number of protons changes the atom. But we also talked about how it's very difficult and requires a lot of energy for us to go in and remove protons from an atom. Okay? It would be difficult. However, sometimes this happens naturally. And you're going to say, well, if it's very difficult to do, how can it happen naturally? There are some elements who have a nucleus that has so many protons and neutrons in it that it becomes unstable. And when it becomes unstable, it will start to release particles from its nucleus. When the nucleus of an element emits particles and energy, we call that being radioactive. So you hear this called radioactivity or radioactive decay. There are a couple different types of radioactive decay. The first one is called alpha decay. When this happens, the nucleus of an atom releases an alpha particle. An alpha particle is 2 protons and 2 neutrons together. When it's released from the nucleus, it also takes some energy with it. And that nucleus then decreases by 2 protons, which means the atomic number goes down and it becomes a different element. In beta decay, a neutron changes into a proton and a high energy electron. Remember when we talked about quarks, how protons and neutrons and electrons are made of quarks? Well, when a proton breaks down and those quarks come apart, what we're left with is so when a neutron does that, we're left with a proton and then a very high energy electron, which is called a beta particle, and that beta particle is released. And as a result, because we have that neutron change into a proton, then the atomic number is going to go up by 1. The last type of radiation releases only energy, but it's very high level energy. Okay? Lots of energy, very intense. Okay? But since it doesn't release any particles, then the nucleus of the atom doesn't change and it remains the same element. All right, this is where our notes end for today.